There is a few problems with free energy, the concept of free energy, and the practicality of free energy. I've studied electronics, but I didn't study the problems with free energy. That was suspiciously taboo. And my assumption as to why was always that it's Nikola Tesla's fault. He's responsible for a lot of our electricity system, and his radio and wireless energy transmission that are ubiquitous among even high schools, let alone university courses, are free energy. You can have a source of high voltage, and you can stick a metal rod into the ground, and you will have electrons that flow from the metal rod to the source of high voltage. And if you stick something in between, you can tap those electrons and they'll cost you absolutely nothing. All you have to provide is a source of high voltage. And if you do that intelligently, voltage is a non-consumable source. You don't use voltage. What you use is current. So you can create high voltage very simply, very easily, very cheaply. And the electrons that flow towards it, you don't have to pay for them. So free energy is taboo because it's very simple. It's everywhere. And until digital came along, every radio station was a free energy machine, or at least a transmitter. Your radio receiver was a free energy machine. And if you work very hard at solving that problem, you can actually use them practically as a free energy machine. It is possible. But it's not particularly easy, and it doesn't work like an on-off switch. The tuning is highly dependent on the ground, and I've done this, by the way, so I know it works. And because of the ground issues, it'll change every time it rains. So the ununiformity makes it a problem for use or for sale as any kind of serious product. But I want to power my house, and it's not very good to do that. I would like a large source of energy, and doing it via Tesla's method is messy. You need to store all that charge that you pick up in capacitors, quite large ones, and then dump them across a transformer, and the resultant power will be a lower voltage which you can actually use. It is possible to do this, but it requires ultimately quite a large machine with quite a large earth rod to produce a usable amount of power, and you end up feeling a bit silly. That's literally the problem with it. It is, we're used to a little electric motor produces a huge amount of power in a small package, and once you start having something that's 100 or 200 times the size of that, and quite expensive to build, it's simply impractical. It may work, and you might be able to disconnect from the grid and not pay for electricity ever again, but you'll probably feel silly from now until the end of time. And that doesn't fulfill the smugness desire, which is of course largely what you want from disconnecting from the electricity grid. Oh, I'm so smart. But actually not really, because solar panels would make you feel a lot smarter. So let me tell you about this little machine that's click-clacking in front of you. This is my Newman motor, what he affectionately called his big Eureka machine. He built one the size of a trailer, and it's easy to see why. He was in a legal battle for 15 years, and no one would take him seriously. So he went, bugger this, I'm going to build one that's, was it 4,000 pounds or 8,000 pounds? It was the size of 3 small trailers It was an enormous trailer with a single coil machine on it, and it didn't produce a lot of energy. The bigger you make these machines, the more efficient they can get, which is good. But you won't necessarily get much more power out of them. He ran his machine on 9-volt batteries, this huge 3-trailer design, but I can do that with mine. And he could grasp his shaft, and he could probably stop the shaft, which was maybe like a 4-inch shaft, with 2 hands. It did not produce a lot of power. It may have only produced a kilowatt or something along those lines. It was ridiculously impractical for its size. I have a much smaller shaft, as you may know from my previous videos, and if I grasp that as hard as I possibly can, I have been unable to stop it with half a watt of input power. So that works really well. So naturally, I decided to give it a name. It's the moustache motor. Okay, cue the slow clap. So my moustache motor, although using a very small amount of power, is also putting out a very small amount of power. I think it is overunit. It does produce more power than it should. It produces more energy than it consumes. It does. I really don't doubt that. I don't doubt that at all. But it's quite difficult to get going, because even operating as slowly as it is now, it's running on 200 volts and well under 20 milliamps. The switching is the difficulty with this motor. I've tried transistors and using relays right now, and it works much, much better with relays, mechanical contacts, which is a shame, because having this sound echo through your house at night is not good. You really want to run a thing on transistors. I'm working on that. There's still a few issues with it. So what I'm going to do in this video series is try to solve the Achilles heel of Newman's energy machine motor, which is to try pretty much any number or type of switches that I can possibly conceive of. That may include building some myself, and see if we can make this machine as practical as it needs to be. And currently these relays are being triggered by Hall effect sensors, which is working perfectly adequately. So I can smell it getting a bit warm. That's because all the power at the moment is only running on half the cycle. Only 50% of the 360-degree rotation is getting powered. Large capacitor explosions and me replacing half these transistors deterred me from attempting that last night, so I decided to just go to bed and fix it today. But these relays look good. I'm going to try and change the timing of them and turn up the speed and take some measurements of the output power. But ultimately I would like to move away from relays and start using modern SCRs. Something from the 21st century would be great. A lot of the transistors I've tried have been sort of circa 1970 or circa 1980 if I'm lucky. Relays are obviously circa 1900. But some of the modern SCR silicon controlled rectifier type transistors, they have all the modern tech in them, and I imagine they'll be pretty incredible. I'm reverent about a lot of things in life, and that has surprisingly included some electronic components. and I fully expect SCRs to create that response in me. In fact, I really, really hope they do, because then I might be able to use them to incredible effect. So, very pleased with the operation of this motor so far. I think there's definitely something in there. Before I shut the camera down, I think what I will do is explain one of the pitfalls of this motor, and basically what makes it great. That huge magnet spinning around in there will, when it's up to speed, generate a force, an electromotive force, in the coil that is spinning the magnet. Let me just explain that again. I'm putting electricity into the electromagnet. That is then turning the magnet, which is pretty normal in a motor. But because there is such a dense field winding, there are so many turns around this coil, the electromagnetic field it creates is so dense that if I short the ends of the motor, it will literally just freeze the coil dead stop. If you've ever seen the trick, the best way to explain it, if you've ever seen the trick where someone drops a magnet through a copper tube, you can literally have a copper tube vertical like that. You can see straight the way down it's a tube. If you drop a magnet through it, the magnet will come, and as soon as it gets inside the tube, it will slow down to, it will almost come to a stop, but it will continue to fall extremely slowly. If you drop a magnet outside the tube, obviously it just falls and hits the table. If you drop it through a tube, the magnetic field it creates on the tube, the eddy currents, create a situation where the magnet field falls incredibly slowly. And it's the same with this coil, where there's so much wire around this coil that has a similar effect. So, as the magnet spins, it generates a force, and the input current drops. If I power up the coil and don't touch the power supply, the motor will spin around. It will use, say, 50 milliamps of electricity. But if I hold the shaft very gently, or indeed not quite so gently, and the speed is consistent for the whole rotation of the motor, then the magnets do something remarkable. This current they generate in the coil itself drops the input power required to actually power it. So 50 milliamps drops to about 2 milliamps in this motor, and that is the whole gain, the whole advantage of this motor. The sheer amount of wire around it causes that effect. Now the problem I've encountered with it is that as the magnets align with the magnetic field, obviously you've got to switch the magnetic field, otherwise the magnets will come in line and just stop. So you've got to continuously switch the field of the motor. And to complicate things further, there is a bit of a spot, a dead spot in the two top bits. When the magnets line up and reach the top, they accelerate a little bit as they get to the top of the field, and that is annoying because that causes an issue that misaligns the effect I just explained. If you've got a constant speed of the motor, then it generates its own power, drops the input current, and you're sweet. But that little extra acceleration bit it does at the top creates a spike on the input power. So I've managed to find a way around that. That is, if you cut the input power at the top and the bottom, so it's utilising that bit, and that bit's cut off, then that solves that problem. That it won't have those voltage spikes. However, it creates a new problem, which is because you've lost a little bit of the speed of the rotation during that period, especially if there's a load on it, then when you re-engage the power, it creates the same problem. It's got to accelerate the motor up again. creating that spike. So what you want to do is keep a consistent speed the whole way around the rotation, and then your power consumption will be very low. So, which is also the state of my camera battery. Let me just check this. As much as I like talking to myself for extended periods, I'll just make sure that I'm not. So, I'm going to buy a 3D printer as part of these tests after I've figured out the switching, and create 3 of these coils and put them in a row. And they're going to be out of phase, so it should basically prevent the misalignment from happening by keeping a continuous speed. I was unable to do that with a flywheel. A flywheel improves the situation by keeping the speed consistent. But if you've got a load on it, it's just not enough. It doesn't make all the difference. There's still a shortfall. But by having basically 3 cylinders, or as many as you want, hopefully that will... 3 will be enough to determine whether the problem's going to be licked or not. Even if it doesn't completely lick the problem, it should get extremely close. But I suspect it probably will, mathematically speaking. So yeah, that's what I've managed to learn so far from playing with this motor. I like talking to free energy engineers. I talked to Thane Heins over the phone about his transformer technology and his electronic acceleration for motor technology. But unfortunately, I got to Newman's motor about 6 months after he died, after he spent the last 20 years of his life trying to make people listen to him, which is a shame, so I would have liked to have talked to the guy. He seems almost as eccentric as me. So, I hope you're not missing out on too much staring straight into my face while I record this. I imagine that's probably the case, but what can you do? Alright. Well, I'm going to shut this down, work out what to do next, and you'll see me for the next update of solving this critical issue. Okay. Bye-bye now.